application to get familiar with new features. And let's look on agenda for today. Today we will look to differences between Qt for MCUs and Big Qt. So for anyone that is familiar already with the normal Qt, this topic will cover a bit of differences and what you can expect if you are transferring from one to another. You will learn how to style the controls, how styling works, and by which mechanisms you can achieve different look for the generally used buttons, sliders, and so on. We will have short coffee break, and then we'll learn how to translate our application to different languages. After that, we will get some rest during the lunch break, and finally, we will see how to integrate our applications together with C++. So how to send some events from QML to C++, how to control different parts of your system directly from QML. For example, if you are going to modify or manipulate some other hardware modules, this topic will be for you. So let's start with differences. And here is what's different by design. So what's intended to be different from the beginning. Version in import statement is optional. So if you are importing any component or any module to your QML file, the version in it is optional. So it's needed just for Qt Creator, and for Qt for MCUs itself is completely redundant and it's optional. So even if you are providing it, it's skipped. Every object has a parent property, which in Qt for MCUs is read-only. It means, well, it's read-only, so you cannot override that one, of course. But more deeply looking onto this, it means that you cannot reassign the objects in QML during the runtime. So this is how they are defined. This is how they will be defined in the runtime, and you cannot modify the tree after compilation. So that's the important thing. List model and list elements are read-only in QML. If you are going to create any model that is going to be changed during the runtime, so for example, you are going to extend the list with new elements, then you have to create the model in C++, and then it's possible to do this. But directly from QML, you cannot define any list model that can be changed during the runtime. If it goes about the fonts, there is no separate font object, so there is no font type in QML. Font is defined inside text elements. So the only way to reference the font is to reference it through the text element, and there is a font property that you can modify. Going further, JavaScript implementation is just a subset of it, and there is a minimal subset written on the slide, but in general, there is no strict definition what that minimal subset is. But for sure, you can use them for property bindings. You can use signal handlers written in JavaScript, and you can write custom functions in JavaScript. So you can be sure that at least those three things are always working for you. Besides that, you have to use strong typing when defining the method, function in the QML by using the JavaScript, and the typing is defined by inspired by TypeScript typing. And well, it's needed as from the yesterday's training. You should remember that all QML files are converted to the C++, so we have to know beforehand how to type some arguments and the return types and how to map them to C++. So that's why strong typing is needed in Qt for MCUs. And there is no support for external JS files, so every JavaScript code that you are going to include in your app has to be has to be included in the QML file. You cannot load external JS file like it's possible in the big Qt. Colorized image is a type that is exclusive for Qt for MCUs, and that's something that is not existing in the big Qt. This type provides you a way to overlay with a color some image that you are loading to the control as a source. It's available in the separate module, Qt Quick Ultralite Extras. It's the module that holds all exclusive types for Qt Quick Ultralite, so for Qt for MCUs. And if you are trying to imagine how this works, so below you have the example of exactly the same approach done in the big Qt. So you are just enabling the layer and you are providing the layer effect with a color overlay, and then your whole image is filled with a color that you are going to set there. And well, in Qt for MCUs is done a different way, as layers for particular components are not supported. So that's why there is a dedicated component colorized image for it. A static text component is something that, in general, it works exactly the same as text on outside. So the text drawn by static text is looking exactly the same how text drawn by a text. In both Qt for MCUs and the big Qt, but the main difference is that the static text holds just strings that are not changing in the runtime, and I mean not changing its size, not changing its content, and it provides us a bit of optimization. So if you know that your string won't change during the runtime, never. Then you can use that to save some rendering time, to pre-calculate some rendering. For example, Qt for MCUs is calculating some text bounds, some margins, positions, and so on during the runtime for text. And by using the static text, you have those things pre-calculated during the compilation process, and that prevents recalculating that each frame in Qt for MCUs rendering engine, and that provides you additional rendering time. Well, that saves you additional rendering time for other things. So that kind of optimization can be done with static text. Well, that was what was different in Qt for MCUs in compared to big Qt. Of course, a lot of types from the big Qt are not available in the Qt for MCUs, but well, let's treat those as just simply not supported, and you can compare those on documentation online. And well, right now let's focus on styling the controls and how to style the control in Qt for MCUs. You have a few ways of doing that, and the first, most simple thing is to provide in-place styling. So each control has properties that defines some pieces of it, like the background of the content and so on. And you can just override those properties with your implementation just in the place that you are using that control. And that's a good way, probably, if you are going to style one control exclusively in a single place. As if you are going to style the whole application, it could be a bit hard to maintain that further, as you will have to change a lot of places with the same code. So the in-place styling is a good way to start with, or maybe with styling the single control in a single place. Then you have the own component in your project. So, well, this is a way better thing to do. So you are creating additional maybe directory that holds your different components. For example, the button.qml, which defines and overrides default button behavior and, well, not behavior, the default button style by overriding the same properties as previously in place styling. But then you are using components from your own project in different places, and you are sharing by this way some custom appearance that you just defined. And finally, the style library is to define styles in the static library that then you can redistribute between different applications. So maybe your system requires creating few applications, and then you can use the style library way to define styles and share them between those. Well, how it's done, I just already explained. So you are overriding the properties that defines parts of your control. So for a button, there is a background and the content item that defines, of course, background, and the content item is defining something that is drawn on the top of the background. So, for example, normally it's a text with a string that prints some information what that button does. For other controls, there are other properties like handle for the slider, which is that thing that we are moving left and right to change its value, and so on, so on. So each control has a set of properties that you can override to define its style. And this is a short example of the in-place styling. So you have piece of your QL UI definition, and you have a rectangle, and in a rectangle we have a button that has a custom background. And by overriding the background property with your style, we are telling that our background will have the background with a rectangle and possibly other things inside. On component means you are creating the separate file, QML file, and you are setting the control as a root of that QML file, and then you are overriding the properties there. And by doing that way, you can reference your component in separate QML file, in other QML files, and you are just then using it as a normal control, but you are sharing it by referencing the single file and by keeping the implementation of your style in the single place. And well, the library. Well, you can mimic the library by creating your own components in separate directory and importing that directory as a module in other QML files, and that's the simple way of doing that. But by this way, you cannot then share your styles between applications. It's just organize your application a bit more. And if you are going to create a custom style library where it means really the static library, you have to use already used by us in our application QML module API, the CMake, and you have to define your own module that will hold your custom styles. And well, this is an example which explains how to create that from the CMake, and you have the add QML module for my style lib, and then URI is my style, and we are providing a list of the QML files. Normally, those files will define the styles. There could be some headers if you are using any imports that are needed by your module, and possibly the resources that are used in your styles. And of course, you have to link with Quick Ultralite templates with a library that holds raw skeletons without styles. Yeah, well, this is just an example how to finally then link your application with style library by just providing your library target into link libraries for your application. Well, I would like just to remind you that if you have any questions, please use Q&A section or chat, and then I can answer all of the things that are not clear for you. Please really feel free to do that. That's not a problem for me to detour a bit to your questions, even if they are not so related to the topic that we are currently talking about. And well, so maybe let's see that example styling. Let's see, C drive, Qt. Qt MCUs. Examples, styling, and well, here are the style custom. Here is the custom style for our styling example. And if you are curious how it's defined in the CMake, here it is. So we are just including those two files that hold style for the button and the checkbox. We tell that our library will need those imports, and we are just linking with libraries. Simple as it. All right, and we are approaching the first live coding session, and maybe let's see what we'll learn. We'll learn, of course, how to style the controls. And before we will start coding anything, I will remind you what do we have from yesterday. So this is our application running on the Renesas device. And we have a splash screen. We added some assets, so we have a nice logo in the background. Let's start the application. We created a coffee selection screen that holds all possible coffees to do. We can, of course, select one of them, and then we are redirected to the coffee parameters screen, on which we can actually change parameters of our coffee. The start button is still not working, but still we can get back and select other coffee like espresso. So this is the state that we currently have in the pipeline, and right now we are going to extend our application with custom styles to have the buttons and the sliders to have those more aligned with the UI. So let's get back to sharing my screen, and I'm opening the coffee maker. So all right, I'm opening the Qt Creator, of course. We have coffee maker project loaded, and right now I'm going to once again use training materials. If any one of you is following live coding sessions, I'm just reminding that if you are lost during some of the last live coding sessions, you still can use one of the steps to align with me right now. And the step which you should take to align with me is step first, and the solution. It holds exactly the state I have right now, and it holds exactly the state that I just showed you on the device. So if you will copy those and then compile, you will be in the same place. And right now I'm going to use prepared files from the step second, and I'm going to files. Let's review what do we have here. We have some custom style for slider. So this is a style that is already prepared. We will create another one for a button. We have some new fonts. And we have resources for button, for two states, for the clicked and normal. The same for the slider knob. Some parts of the background for the slider that will be adjusted depends on the size of it. Well, so I'm copying all of those, and let's get up. Let's go to Coffee Maker, and I'm pasting it to the root directory of our project. Replace the files if there is a need for it, and minimize. And right now we can start extending our application with a new style. So I'm going to cmakelist.txt file. The first thing will be to add new resources. Let me just copy those list of those files. So it's button down, button normal, slider down, slider normal, slider background center, slider background left, right, and slider fill center left, right. Here we go. If you are going to copy those, there is also a list of the files available for you in the Let me show you. The file list.txt holds the list of the files that you can just copy and paste like me before. All right, so these are the files. And right now we are going to add the custom style for the button. To do that, I will add new QML file that will hold the style. Add new Qt QML file, Qt2. Let's call it button. QML, of course. And I would like to hold this in controls directory. So our coffee maker root directory and then controls. Select the folder, next, and finish. All right, file should be created right now, but we still have to add this file to our QML sources. So the controls, button.qml. Save the file. And I'm opening that file right now. It appeared on the left side. And right now it's just an empty QML file. And I'm going to extend this with our custom style. So for sure, I will need templates that is the module that holds styles. Not styles, that holds skeletons for our buttons and controls. Quick templates. The version is optional, so it's not important which is it. Button, and let's try to extend it with our implementation, and we will use some ID for sure. Button control. All right. Well, I will set some paddings and margins and insets, and before that, maybe I'll explain you why and how that works. Open the browser. I will use the Qt FreeRTOS documentation for it. So here it is. And if I'm talking about some properties to define the style, so of course there's a width and height. We will also use implicit width and implicit height. So the implicit size is something that is a recommended size. So if we are not setting height and width, then the implicit width is used instead in height. If we are talking about insets, it's a distance of the background from the overall canvas of your control. And if we are talking about padding, it's the space between canvas and the content item. So those are the properties I will use to style our control. Let's define some of those. So the paddings are first. Top padding. Bottom padding. So 10 right. Insets. Right, 2. Right inset will be 5. And left inset 5. And well, right now I will just copy implicit width and height to not make any mistake there. And I'm explaining you how it works. So well, implicit width and height is just based on the background, which we'll define shortly. And it's adding some insets and paddings to just make implicit width and height the size of the background and the spacing that is needed to show it properly. All right, so let's now define some utility properties. Text size, some alias property, and alias property will just forward the other property that will be inside, and then we will be able to modify that alias property from outside. Well, but before I will tell what alias, I have to define it. Okay, so I will define the content item. Which will be just a text with an ID. The text will be button control text. So our root ID, and then we're referencing the its property text. And right now the button text color can be aliased. So we are referencing the button text color. All right, so by changing this alias globally, we will change the color of that text, which defines the content item for us. Let's change the font. Its pixel size will be equal our property, and it will be bold. And horizontally align to text horizontal center. Perfect. And the last thing we are missing, it's a definition for background. And our background is just an image without ID. And of course, our source will be different if we're pressing a button or not. And the skeleton that comes from Qt Quick templates for the button have already some property for it. So button control, and we are checking if it's down. If it's down, of course, it's pressed. And if it is, we are picking one asset. Button down, of course. Down. Is not. We are using button normal. Okay, let's save it. Let's try to build our application for the desktop, just to verify if anything is broken. Something it is. Let's verify what is. Bottom padding, there is a typo, of course. I used N instead of M. Let's try to compile once more. Another problem. Cannot convert from font weight to font. All right, something is wrong here. All right, so this is a problem. There shouldn't be any column there. Okay, it works right now. All right, so we are sure right now that we don't have any typos or configuration problems. So let's try to use our button on the splash screen. So currently we have the normal style default button, and we are going to use right now our style. So we no longer need the import of the default controls. So I'm removing that one, and I'm importing directory, which holds our styles as controls, and this could be any name. And right now we just have to reference our button from that module. All right. Let's try to run our application right now. And here we go. Currently, we have a nice styled button with a new font, with a new background that can still click, and that we can still click and start our application. But as you can see, we still don't have any style for the button that is, for example, inside Coffee parameters screen, and we are going to change that. So we are going to Coffee parameters.qml. And as well here, we are removing default import for default styles. We are importing directory controls as Coffee controls. And let's see, where is the button? Okay, here it is. And we are referencing the button from Coffee controls module. And let's verify if that works. Here's normal, and we have our custom button in our Coffee parameters screen as well. And if you are seeing properly, the button is changing the asset once it's pressed. So it's working exactly how we designed that. And we are sharing the single implementation of the style from the controls directory between different components of our application. Let's right now add the custom style for the sliders, as those are still not aligned with our UI. And this style is already prepared. So let's go to CMake list.txt file and let's add the slider.qml style to the compilation. All right, and the second thing to do is to modify our Coffee param slider file to use that style. And here as well, I'm importing the controls. It's Coffee controls, and our slider has to be referenced from there. All right, I forgot to save the CMake file. All right, let's try to run it. And here it is. Let's open Coffee parameters screen. And here we go. We have new style for our sliders. Let's quickly review what's inside the slider.qml. So the style that was prepared beforehand holds, of course, some implicit size, holds some pre-configuration, and of course holds definition of background and the handle. Handle is, of course, just an item that holds an image with some offset. We are, of course, changing the content, depends if we are pressing the handle or not. And our background is combined with the left and the right side of it with rounded corners. And the center part, which is just a rectangle in the color, is scaled horizontally, depends how far our handle is moved. And this is how it works on the desktop, and let's verify if that works on device as well. So I'm pressing compile and I'm switching the view to secondary camera. We will have to wait a bit to compile and flash the application to the device. So okay, the flashing process is ongoing. All right, so here it is, our custom style for the button on the device. Let's verify if Coffee parameters screen are working as well. It seems they are working. The button is changing the color. It's barely visible, I think, on the camera, but trust me, it works. And the sliders are also working there. As expected. So Oh my God. Upside down is really hard to. Oh, here it is. Okay. All right. Let's get back to showing the screen. And right now we have all controls that are used in our application styled. So to prove that we no longer need linking additional library with default styles, we will remove that linking. So let's go to CMake lists and let's find where we are linking default style. Here it is, and we no longer need default styles. We just need a raw skeletons of our buttons and sliders and in general controls to have the behavior, but we are providing the style for it. So it's called Qt Quick Ultralite templates. And that's just it. I'm just switching to desktop once again. And let's prove that we are no longer using any default styles. All right, so it still works, and that proves that we are not using any of default styles in our application, right? All right, let's get back to presentation. And right now we have a short coffee break. So do you have any questions regarding the styling or maybe some previous topics? I can answer those Q&A sections for you. In the meantime, I will prepare the timer with a 15-minute break. So if there are no questions at all, I'm starting the timer, and let's see in 15 minutes. All right, welcome back after the coffee break. And let's see what's in the pipeline. Internationalization. Well, I pronounced it finally. So, for those who don't know, I will explain how Qt Linguist tool works shortly. But first of all, let's in overall discuss how translations are done in Qt for MCUs. So it bases on the same approach that the big Qt, and well, it relies on the tool called Qt Linguist, which provides translations for translation files for our applications. And how do you tell Qt for MCUs that some string is translated? It's done by using QSTR function to mark the text that is going to be translated. And here is the short example on the left side, that your string back is just covered and wrapped in the QSTR function. And well, let me right now explain how it works together with Qt Linguist. So you're adding new content to your application. Let's look on the right side on this diagram, and I'm on the top of it in the most green one. So we are adding new content to your application, which of course is using QSTR for all of the strings that are going to be translated. Then during the compilation process, Qt Linguist tool is getting through all your QML files and is looking for QSTR occurrences. And by detecting those, it's creating the translation files with a XML structure to fill your translations there based on those QSTR content. If your files are already existing, then the files are just updated with the missing strings, and these strings that are still existing and are already translated are not touched at all. So this provides you a way to incrementally add new translations to your app. And then if you are going to provide translations, you are just using Qt Linguist tool in the graphical form to fill missing texts by, I don't know, by you or by some translation team. Then you are building your application, and Qt for MCUs APIs are embedding those translation files in your application in binary form, and you can release your app. And if you are going to create some updates for it, the flow is exactly the same. So you are adding new QSTR things in your app. Then Qt Linguist tool is parsing QML files to search for new occurrences. It adds those new occurrences as an empty translations to translation files. You are updating those using Qt Linguist graphical tool, and you are building your app once more and embedding those translation files to your app, and you can release your app finally. It comes with some limitations. The most important one is that from the C++ you cannot provide any translate string. So all of your translations has to be located in QML. We do not support in Qt for MCUs other translation functions than QSTR. In the big Qt there are some more, but here is only that one. And plural disambiguation is not supported, so you don't have a plural version of your translated string. You have to work out this in a different way. To check the current language, it's also something different between the big Qt and the Qt for MCUs. So Qt for MCUs has exclusively the Qt UI language property, the global one. You can reference that and access that from each QML file you are writing in your application. It holds currently set language as an ISO language code. And it's used for checking which language is set. It's used for switching the language, and for checking if no translation is applied, then this property holds the empty value. From the CMake side, there is a special macro for handling translations. So you're defining translations by calling Qt target embed translations, and this creates two things. So this creates a new CMake target update translations, which you have to run to trigger Qt Linguist tool, to parse your QML files and generate translation files or update them. And then it also is tying your translation files with your binary, so translations are available then during the runtime for your application. Probably it could be worth mentioning that if you support different languages, probably you will have to extend Unicode coverage, as different languages and regions have different glyphs to render. And you can do that by providing additional blocks or exact values of Unicode characters to font Unicode coverage property of text. So in one of your text elements, you just have to provide additional Unicode coverage, which can be the whole defined block, which you can find on documentation online. You can provide the range of the glyphs by providing the start and the stop values, and you can provide an exact literal with a single character you would like to pre-render. And right now we will try to do some live coding session to learn how to translate your app in the real project. And to do this, I'm just switching to Qt Creator, and let me prepare for it. So, all right, we are going to training materials, and I'm picking step 3, files, and we have to copy all of those without file list. Copy. Let's get back to Coffee Maker directory and paste. All right, let's get back to Qt Creator. And I'm opening cmakelist.txt to modify our project to include some new resources and some files that will be needed. Once again, I will copy resources. So these are new for button language normal and down. So 2 states for our new button that will be for pop-up with changing the language, some selector background for the radio button. For radio button we have on off, and the language selector background is just a background for our pop-up. Next thing to do is to extend our our QML files list with a new style for radio button and some new QML files with implementation of the pop-up itself. All right. And right now we have to define our translations, and we are doing this by just adding cul target embed translations, Coffee Maker, and we are providing translation files names. .ts, and for the French, frts. Perfect. So, all right. This defines translation files for Coffee Maker, but we still need translation files for the same translation files for helpers module. So the same for it. It won't generate a second set of translation files. It will just generate, well, it will use the same files for translations for the helpers module and for the Coffee Maker. So that's a cool thing, I think. All right. And to make sure that always we have our translation files up to date with our project during the compilation, we can add the custom build step before building our app to regenerate our translation files. And right now I'm going in Qt Creator on the left side to projects, and I'm going to add custom build step for for desktop and for the Renesas board. And first I will take care of desktop. Let's scroll down a bit on the right side and find build steps. Add build step, custom process step, and we are going to use CMake. So let's browse for it. It's of course located in the Qt directory, tools, CMake, bin, cmake.exe. All right. And we have to provide some arguments to trigger the CMake with a proper target. So we are going to build a current directory with a target update translations and move it as a first build step. I will copy this. Working directory is the valid one. All right, and the same for our board. Add a custom build step, select CMake as previously. Let's provide the arguments and move it to the top to be the first one. And that's it. So right now we are sure that each time before building our application, we are running update translation target, which will update our translation files. And okay, right now, let's verify if we have translation files anywhere. So we do not. And right now I will try to run our application and let's see if our update translation targets will generate files for us based on the QML files we have in the project. So let's get back to the project view, select desktop, release. Okay, it's for the release, right, okay. And start. All right, so we have our application ready. Let's review if anything changed. And there is a new button on the left top corner. Let's click it. And there is a language change settings pop-up that can be used to change the language. For now, of course, it does not work. We will provide translations in the next steps. But let's verify if we have translation files ready. Here they are. And let's try to open those with Visual Studio Code and verify the syntax of it. And as you can see, this is a pure XML file with some strings and with empty translations there. And let's verify if we have our string from the start button from this splash screen. And we do not have. So why is that? All right, so that's because we didn't use the button. All right, splash. We didn't use QSTR function there, and we are going to fix all of the occurrences of the text that are not using that just right now. So let's add it there, QSTR. Save the file, and maybe let's search for it in the whole project. Right. Search. And okay, let's go. Here is the first one. QSTR. Save the file. Language settings. There's another one, even two. QSTR. QSTR. Okay, and in this splash we already fixed helper functions. Let's see if anything needs fixing. Okay, there we have those, and let's see that there is a small difference. QSTR holds two arguments, and this is a cool feature. As we are using normally QSTR with a single string that's going to be translated, but sometimes while you are translating things, you need a context. So you still need to know what is strong in this context. In different languages, strong coffee can be translated to something different than just a strong. So you can provide a comment for the translator that will help him understand the context of your translation. Let's try to build it once again and verify if that helped with our problem that we didn't have start string included in our translation files. Okay, let's close it as we didn't change anything in the UI, just verify translation file. Let's search for start, and here it is. It's even marked as splash.qml file, but still we are missing translations, and we are going to add some translations right now. Well, so let me show you how Qt Linguist tool looks like. Here's the Linguist tool. Sorry for having a Polish language there, as this tool is checking for the region instead of checking for the language of the operating system. But I will probably explain everything that is needed there. And let's open translations for the German language. And we are going to translate some strings, but first of all, let's see how those comments are working. So here we are picking the file that holds the strings that are going to be translated. Then in the center column we have strings, exact strings to translate, and on the right side we have a context from the source code. And below we have the string that is going to be translated, and then the comments are going there. So the translator will exactly know what is the context of that string. Well, and let's try to add some translations right now for the German language. So I'm picking language settings and then language settings string. And I'm going to translate it to the German. And for a save, it's that thing. Do not forget to save the file with that floppy disk icon. And we can close and compile our app to verify if those translations are working. Okay, let's start, and those strings are located there. So if I will switch to the German, language settings and the save button should change. And here it is. So it's as simple as that. But still, the rest of the strings are not translated, and we have prepared specially prepared rest of the translations already, and I'm going to training materials, step 3, solution, and I'm copying those to translation files, and I'm going to paste those to our project. Replace and run it on the device. Sorry, first we'll run it on desktop, and then we will verify that on device. All right, let's switch to German language, and here it is. So let's look on the left side and the right side. The strings are right now in German. The start is, of course, exactly the same in German language, so that's why it didn't change. Let's verify the French. And here as well, as you can see, we have a different language. Let's verify that one on a device. Let's build that one, and shortly I will switch my view to secondary camera to show you that the translations are working also on the device. Okay, board is flashing right now, so I'm switching the view. Okay, so here we have our application, and let's verify the translations there. Let's select German language. And strings are right now the German, and let's verify French. It's also working pretty fine. So this is how you translate your application to different languages together with Qt Linguist tool. I think it's a quite straightforward thing and should work without any problems in your projects. Do you have any questions regarding translations? All right, if not, so there is a time for the lunch break, exactly as in agenda. So I will modify the timer to 45 minutes today, and let's see each other after the lunch in 45 minutes. All right. Slowly we are getting back after the lunch break. Still, please give me a few minutes to prepare for the next parts. All right, so the next topic we will cover is the C++ integration. It's the last topic for today and probably the most complex one. This topic will learn you how to integrate your applications together with some backends written in C++, which then can of course connect to C and manipulate other hardware components in your project or system. For example, let's imagine that you are connecting your device to some Wi-Fi and you would like to pass some information to the hardware to which network you would like to connect. And this can be done by providing that information from the UI, from the user directly to C++ and then around the code itself. So you can also use that to create some business logic that can be too complex to be written directly in QML. You could also do some custom stuff in, for example, custom main function that can be of course used as you wish. And how that communication works. So each class that you are going to expose from the C++ to the QML, for sure, its name will define the QML component of the same type and the name on the QML side, and it has to inherit from QL object. That's the mandatory thing. And from the CMake perspective, you have to use tool target generate interfaces macro to make this C++ class visible to other QML files from your project. And well, how such interface will look like on the QML side? It will be just another QML object with mapped properties and the functions. So you can use all of those normally as other QML types around your project. And here's a short example that you have some header in which you are defining a struct big state that inherits from the QL object and exposes some QL property of type int, which is a brightness, some function which returns an integer and takes an argument with a type int as well, and it also exposes some signal that is just a raw void function, and this will be translated to the QML side to some big state QML component with properties and functions of the same type as on the C++ side. And how to use such things? Let's focus, for example, on the properties. And if you have some struct my data exposed as on the following example, with a property strength, on the QML side, you can instantiate that my data struct with some ID, and then through that ID, which in our case is a data, you can just simply access that strength and overwrite its value or read that value or something else. It works exactly the same as every other property is defined purely in the QML. There is no difference between those two. The main difference is that it's your C++ code which you can write as you wish, and you can implement your own logic directly in that language. You can, for convenience, also group the properties. So in exposed structure, you just have to create another structure inside, and then use that to create a group, and then define that group to have some access name on the QML side. As I said, types are mapped from the C++ to QML, and this is a short table how it's done. So bool is bool. Integral types are just an int on the QML type side. Floating point types are just real on the QML. STD string is a string. Pointer to type, which derives, of course, from QL object, will become a T component on the side of QML. So if you have, for example, pointer to my data structure, that pointer to my data structure will become just a my data structure on the QML side. And of course, the enum will match the enum type on the QML side. Which functions? I told you that functions are exposed as well, but there is some simple rule that function that you are going to expose has to be public. That's the first requirement. And second thing is that function cannot be overloaded. And then you can access all of those functions on the side of QML as it's presented on the right side. Signals are exposed just as signals. You can work on them and use them exactly in the same way as normally signals defined in QML. So there is no difference at all. They're exposed exactly the same way as the properties. Yeah, there are some convenience implementations of some design patterns in the Qt C++ APIs, like for example Qt singleton, which makes easier to, for example, expose some class globally to whole QML project. And in this case, you are just referencing it by the name of your class on the QML side, and then you can access some properties or functions directly from there. In the list model, there is this is the only way to create read-write models in Qt for MCUs. So to expose a list model of a given type from the C++, and on the left side, you have an example of the price list, which is a list model that holds elements of the type commodity passed as a template argument. And then you have to override two functions, two methods, to be honest. And so the count that returns the size of your data internally, and of course the accessor method for a single element based on the index. So a data method that also needs to be overridden. It just has to return the element on the given index. And how the modification can be done? You can expose some function to add some new elements. Then you are modifying your internal data container, and you have to call model reset. And this is not an ideal thing, as you have to know that calling model reset will cause the whole list to be redrawn. It's not only redrawing that new particular element. This suboptimal solution is right now the only way to update and trigger the redrawing from the C++, but we are working on it to improve that functionality to have some partial redrawing, also in case of updating a list model. On the right side, of course, you have example how to initialize such a price list and how to use that on the list view by just passing that price model ID, which refers to the price list object, to the model property of the list view, and then in the delegate you can reference the model dot property name or some other properties that are located in the type of the element that is passed in the template argument of the list model on the C++ side. Custom main function, well, it's also possible to do this, and we are currently in our application using the app target default main, which provides you the most common and the default implementation for the main function. And if you are going to define your own, you just have to remove that call from the CMake, and you have to define your own following the pattern that is currently on the screen. So you have to call init platform for the QL, you have to initialize the application class, and you have to initialize the root item of your application and set it to the app, and finally run the exec endless loop, which will start rendering. If you are going to add some custom code, you can add that in between where your code comes here comment is located. Event queues are the fine way to pass some events across different parts of your application, and that could be a QML part, and that could be a C++ part, which is even not exposed to QML at all. So you can, of course, control the overrun policies. So if your queue is full, you can decide what to do with new events. So you can discard new, and that's the default behavior. And you can, of course, override the oldest, which will mean that, of course, oldest will be gone, and the new event that is incoming will appear in that place. Well, you can also override some convenience method on queue overrun to see if your queue is too small, and maybe you could extend its size. The default size is 5, so 5 events can wait between the frames to be delivered. And well, that's a super important thing, that order of the events is kept only in the scope of one event queue. So if you have an event queue that is sending one type of the message, the order is kept in this one. But if you have the separate event queue with a different type of event, then the order is undefined, and you cannot rely on that without any custom synchronization. Well, some example of the event queue. So there is an input event defined on the left side, and type of that event is defined inside the struct. We have some union there to pass different kind of data, and on the right side you have some component that is going to be exposed from the C++ probably, and it also inherits from the event queue of the input event type, and it overrides the function on event that will be called each time anyone is sending the message in the event queue. Well, this is how we are posting events. So we are just calling the post event function from the event queue, and we are passing the message initialized before. And we are going to use those things in the live coding session. You will, of course, learn how to create C++ object and how to use it in QML, and how to create a list model and update it in the runtime. Let me prepare. All right, so we have our application. We are finishing from the state we finished previously, and we are going to add new C++ class. So add new on right, click right on the project, add new C++ class, choose, and let's call it BrewTimer. All right, and we are going to create a separate directory for it, source. Select folder, next. And we have to add this new file to compilation. And to do this, we just have to add target sources for coffee maker. These are private source BrewTimer C++. Okay, it appeared on the left side. Let's open this, and let's switch to header to define how our interface to the QML application will look like, and what we are doing right now. So we are going to provide a functionality to brew our coffee. So we are going to simulate brewing, and I'm going to create some kind of a pop-up with a progress bar that will be moving in a time based on the arguments that are the parameters that are set in the parameter screen. So if you will, for example, choose the bigger coffee, it will brew longer, and so on. And we are going to expose some mechanics to track that status. So All right. Maybe let's get back to CMake lists and let's expose that header to the QML. So qul target generate interfaces for coffee maker, and we are exposing the header from source brew timer.h. Okay. All right, so let's get back to the header file. So I'm clicking on the C++ file, then switch header source, and let's try to add some includes. We will need for sure. We would like to access our class globally from multiple places. So I will create it as a singleton. We would like to expose some signals to track the status. So we are going to expose the step signal. So it will be called each time we are doing the step in the brewing. And we are going also to expose some signal to notify when the brewing has finished. So for sure we need signal. Some timer to simulate elapsing time. And we will be using some integers, some stdint. All right, to make it more clear, I'm switching class to struct just to get rid of the public, and I'm inheriting from the singleton. This singleton is of course of type of our class. All right. All right, we need some way to tell that brewing has started. So let's expose the function start brew, which will take arguments with the parameters. All right. And let's expose those signals. That will be a way to track the brewing process. Some brewing finished and some signal for brewing progress step. All right. Some private things like timer. All right. So we have our interface to communicate with QML ready. And let's try to build that. No, I'm building that for the device. So let's switch to desktop. It shouldn't matter, but it should be a bit faster. All right, application has been built, and right now I'm going to show you how this generated interface look like in the intermediate files. So I'm going to open Visual Studio Code with our training directory, and let it be next to the C++ interface. And let's find brew timer, but in the QML. Yep, here it is. So this is auto-generated QML interface for our brew timer. And as you can see, it forwarded the public things that are our function that takes 3 arguments and 2 signals, brewing finished and brewing progress step. And by using that QML file, our other QML files will know exactly what things are available in our interface. All right. So right now I'm going to copy rest of needed files to save some time. Where did this training? And I'm going to training materials. Last step files. I'm copying all of those, and let's paste that to our application directory. Some updates, some new resources, of course. Yes, refresh all of those files, and let's go to cmake list.txt and let's extend resources and the files from there. Wait, sorry. So we have two new resources, button log normal and log down. So this will be used for history menu. And we are going to add new QML files as well. History button, history, and history list are responsible for drawing our history. And brewing progress is just an implementation, simple implementation of the brewing pop-up that we are not going to implement ourselves. We're just connecting the interface. It's rather an easy thing to implement some rectangles and buttons there. All right. And we are still going to add new headers, new interfaces to our CMake project. Let's find generate interfaces. Okay. So in generate interfaces, we have some coffee model, of course, and the timestamp. And in the target sources, we have to add timestamp. And just to make the things visible, I will add coffee model. I will show you how it looks like later on. Let's try to run our app. All right, let's review what's changed. The start button is still not working. We have a new view for the history, but let's just prove that nothing is showing there. We are going to implement the start button, so with a pop-up for showing the brewing progress and the history, which will be then filled with new coffees that we have brewed. All right, so we have our brew timer implemented right now. So there is some simple implementation for simulating the brewing time. And we are calling, of course, our signals there. The brewing has made the progress and brewing has finished. And we are right now, we are going to use that interface in the QML to watch those signals. And let's go to coffeemaker.qml. And let's find brewing progress. Okay, here it is. And right now it's something that is not used at all, so we are going to modify that a bit. And we are going to open it from the coffee parameters. And in coffee parameters screen, there is a signal that we can watch on start brewing. This signal is called whenever user is picking any coffee and clicking start. So if anyone clicked start, we are going to modify the opacity to 20% of the parameter screen. And we are going to show the brew progress. And still, we would like to start brewing in our simulation. So let's reference it with a name of this track we exposed. Start brew. And let's pass the arguments. Strength, Do not forget about the commas there. Capacity. And the temperature. And let's try to build that, save the files, of course. Okay, we have some unresolved symbol for start brewing. So probably I did some typo. Start brew. Okay, I did some typo, but not in there, inside here. Start brew. Let's find where is the problem there. Start brew, exactly the same. All right. Coffee maker.ql, start brew. Let's verify that once again. Okay, it's a strange thing. Let's verify if the file that we have added to the sources is compiling. It's a strange thing. Let's clean the project. And let's build that once more. Sometimes it just needs some refreshment. All right now we have another problem. Okay, there is a typo. Let's try again. All right, it works right now. So let's verify how it looks like. All right, let's start the application and let's verify if our start button is right now working. So we have the pop-up shown, but still the progress is not appearing, and it's because we are not watching any of those signals yet. And right now we are going to change that. So let's go to brewing progress. All right. And let's scroll down, and here where is the comment? Let's watch our signals. On brew progress step, and the signal handler will just increment the bar with 1 pixel. All right, let's verify. So espresso start brewing. And we are expanding a bar, but not the one we would like to. So let's search a bit. All right, because I entered the wrong probably item. Yeah, it's not with, it's a bar with. And right now it should be fine. Right, let's verify with Cafe Mocha. And as you can see, the brewing progress is right now working, but the pop-up is not closing on the end, and let's fix that. So we are watching the brew finished. And once the brewing is finished, we are going to modify the text that is displayed on the pop-up to done. And we are going to start some small timer to simulate some delay to make sure that done string is visible for a while. And then while finish timer will elapse, it will just close the pop-up itself. Let's verify that. Start with FreeRTOS, let's start brewing. It's done, and after a while it's disappearing. Let's verify that history is still empty, just to prove you. It's still empty. All right. So we just integrated our brewing timer into our application. So we have a full cycle of brewing. And right now we can start integrating a history interface to our application. And to do this, we are going to use prepared coffee model, which is of course a list model that holds coffee model data. And this model, of course, implements two required functions to retrieve item and the size of it. And also it exposes some new function for adding and modifying new elements. And we will use this one to add new elements to the history. So let's initialize our coffee model. Let's try to find the history somewhere there. It's there. So our coffee model will have an ID coffee model. And to use that in the history, we are using property model. And we are passing coffee model there. All right. We can look on the history. So the model property is just an alias for history list model, and history list is located below. And this history list has a property coffee model that holds our model and then passes that to the final list view. So this is how it works. We can still try to run it. And as our model is still empty because we are just initializing it, we still should have an empty history. Here it is. and we should still have empty list because we are not adding anything anywhere after brewing a coffee, and the history is empty. And right now we are going to add that modification to the history model. So let's go to coffeemaker.qml. We need some helpers, as we are going to use some string conversions from there. Okay, and let's find on brewing finished. It's there. So after coffee is brewed, we are going to reference the coffee model and add value with some arguments. First will be the helpers function with helper functions will help us to retrieve the coffee name from the index that was the last brewed coffee. We are going to pass the strength, also capacity, temperature, and from the helpers, current date, plus concatenate some space, and plus timestamp current time. All right, and let's try to verify if that is enough to fill our history with new content. And we have some compilation errors, so I did a typo probably somewhere. All right. Did I expose the coffee model from there? Interfaces coffee model, it's exposed, it should work. So let's clean it once more. Okay, run it again. Now let's find out why the compilation is not working right now. Okay, so I referenced some property, probably I made a typo. Current date, not data. Right, now it should work. All right, so let's verify that history is empty. It is, and let's brew espresso. It's done. We are hiding the pop-up, and right now we should have a history filled with espresso. Let's verify if I will change the coffee and the parameters, it will reflect exactly the same thing. So temperature is high, big, and the mild coffee. Mild, big, and high temperature is for our cappuccino. So exactly as expected, our coffee model is working and is filled by our new elements directly from the QML, but through the C++ and exposed to the QML. And by doing this, we finished our application. So the last thing is to verify if that works on the real device. Well, I will just clean and rebuild it from scratch. And I will right now switch the view to secondary camera. This is still old content from our application. The flashing process is started. Right now, the flash memory is programmed. All right, so let's verify the brewing on the real device. Let's brew espresso. Well, let's verify the history. And it works as well. Let's maybe pick another language. Let it be French. Okay, and let's brew some other coffee. Let's get back and verify the history. And the history is also filled properly with a new coffee right now. So our application works exactly the same way as on the desktop. So let's get back to presentation, and let's see what's on the roadmap and what we still have in the Qt for MCUs besides those features. So there is a monotype Spark font engine which can be used to dynamically generate the glyphs and to save some memory on your device. We have also a 2.5D transformations, so you can create, for example, a carousel view with some more fancy transformations as well. You can do off-screen rendering to generate some images, for example, in your app. We are supporting hardware layers. Some of you may remember the hardware layers from the Amigas. So this works in a similar way. We have Qt Quick Ultralite Shapes API for vector graphics on 1170 and other boards that supports that features. We also support building Ultralite as a static library, which can be useful to create some more advanced ecosystem for the compilation. And what is going to be added in the future releases? So we are still working on improving tooling support, for example, in supporting the Design Studio and in support better Qt Creator. We are still adding new reference boards, so please stay tuned with us and look what will be new in this case. We are still adding new compilers and tool chains. We are improving platform abstraction to make sure that any custom modifications to Qt for MCUs is as easy as it's possible. And as I said at the beginning of the training, we are also going to add Linux host support within the 1.9 release, which is really soon. So please stay tuned. And this is all for this training. So thank you very much. If you have any questions to me, so please use right now the Q&A section. You can also leave some feedback on the email as well. You can still send the questions on the email if you have any. So thank you very much, and I will wait a minute maybe for the questions that you may writing right now. But if not, I will just thank you again, and then we will finish our training. All right, I don't see any questions incoming, so if you didn't have enough time to write those, please forward me them to my email address, which is currently on the screen. And thank you very much again for attending this training. and hopefully we'll meet on more advanced in the future. So we will learn more fancy things and more deeply about Qt for MCUs. So thank you very much and goodbye.